Hello students, welcome to the new video of digital electronics. In the previous video, we have already seen how you can derive or reduce the given Boolean expression with the help of Boolean laws. Those laws like De Morgan's laws, idempotence laws, identity laws, etc, etc. So those laws were responsible for getting you the reduced Boolean expression. Now in this video we are going to derive entirely new Boolean expression with the help of given circuit. That means in the example you will be given a circuit diagram like this as shown in this slide, and you are supposed to derive the equation with the help of this circuit diagram. The equation just now I have written down like this, right? So this type of equation you are going to get. This is a Boolean equation in which there are A, B, C, D inputs written down as per the circuit which is given to you. And the circuit diagram will be obviously including gates, basic gates, right? So therefore, these gates are going to give you information what will be the output of this specific gate. Therefore, deriving Boolean expression from given circuit diagram is what the today's agenda. So let us see how to do that. Now here I have drawn a simple diagram in which there are two logic gates. One logic gate is here, as all of you are well aware. This is OR gate. And what will be this? This is AND gate. Now in this circuit diagram there are three inputs. Out of these, two inputs are given. The inputs are A and B. These two inputs are given to OR gate, and the output of OR gate is passed through as a input, one of the input of AND gate, and second input of AND gate is this C. Now what you are supposed to do? What will be the output at this particular terminal? What will be that? This is what you want to find, and this is what the topic's title, that is deriving a Boolean expression by using this circuit diagram. So let us identify what is given to you. So this is a OR gate given to you. You know that already, that if OR gate is connected as the in this particular case and the inputs are A and B, then output of OR gate will be A plus B, right? So OR combination or OR word will be replaced by plus sign, and A and B are the inputs. So therefore output of OR gate will be A plus B. Now this output of OR gate is given or acting as a input of AND gate, and another input of AND gate is C. So these two inputs now given to AND gate. The AND gates terminology is that any inputs, if any number of inputs are given to AND gates, then the AND operation or AND logic will be replaced by dot sign, right? So dot symbol will be placed between the inputs. So here the inputs are A plus B and another input is C. So at the output side you must get dot combination of these two inputs, and it will look like this, right? So the two inputs A plus B, which will be now written down inside one bracket, dot C is the output for this particular circuit diagram, and whatever you are getting here as the output, which is Y, is what your Boolean expression. So therefore this is how, with the help of given circuit diagram, you get the Boolean expression. So this is your final result. So this is a very simple circuit diagram which gives you three inputs and their output will be like this. So this is a different combination. Now let us look at another example. Now this is a little complicated one, and this was written down in the first slide of the introduction of this particular chapter. So here you can see there are four inputs A, B, C, D written down like this, and this complicated circuit diagram has got only one output, which is this, and which we want to find. So the output whatever the equation at the output is our Boolean expression, required Boolean expression. So let us go from input side. So for A input, here you can see this is a NOT gate connected. This is also NOT gate. This is OR gate. And this is also OR gate. Now these two OR gates are receiving inputs. Now this OR gate number 1 has received input through these NOT gates. That means A, which is input of NOT gate, will be complemented at the output side. So here instead of A, it will be A complement, right? So A complement will be entered as an input to this OR gate. Now this C is again complemented. So this C, after complementing it, will become C complement, and this C complement is given as input to this OR gate. So the inputs to this OR gates are A complement and C complement, and we know already the logic of OR gate is that if there are two inputs, then provide plus sign between the two inputs. That is what the OR gates operation, right? So logical plus sign. So I am writing down first input as A complement plus second input as C complement. So this is the output of OR gate, which will be in turn acting as an input of last AND gate. Now let us focus to the remaining two inputs. The remaining two inputs are B and D. Now these two inputs B and D are acting as inputs to this OR gate, and you can see this B line or B signal is directly given to the OR gate, and D is also directly given to this OR gate. So therefore OR gate's terminology is that provide plus sign between the two inputs. So the two inputs are B, second input is D, so B plus D is the output of this OR gate. Now these two inputs will be acting as outputs of OR gates will be acting as an input to this AND gate, and AND gate says that if there are two inputs, then place plus dot sign between the two inputs. Here the two inputs are not a single character or single variable, these two variables are present. So therefore I am writing down first input inside one first bracket, that is A complement plus C complement dot. Now turn off second input, but second input is also another equation which is B plus D. And this is your required Boolean expression. So Y is equal to A complement of A plus complement of C dot B plus D is what you are going to get at the output side, right? So this is what example. This is how a circuit diagram can be identified, and then the respective Boolean equation can be derived. Let's go to next one. Here again you can see the NOT gates, OR gate is present, AND gate is present. So therefore this is what you want to find, the output of this AND gate, right? Final one. So therefore starting with this A and B, because these two are inputs to this OR gate. So therefore this A1 input to NOT gate will be complemented as A complement. And this B, which is input to this NOT gate, will be complemented as B complement. These two are given as an input to the OR gate, right? This is OR gate. So OR gate's terminology is that provide plus sign between the two inputs. The two inputs are A complement. So first input is A complement plus second input is B complement. This will be the output of OR gate. And now this C signal is acting as an input to second input to this AND gate, which is C. So therefore AND gate's logic is that whatever inputs are there, place dot between the two inputs. So therefore now you are going to get final output as Y is equal to, inside first bracket, A complement plus B complement. This is your first input and this is second input. So this is what Boolean expression for this circuit diagram. Now let us see what will happen to this one. Here there are two inputs and there are NOT gates, AND gates are present, and then there is a OR gate. We are supposed to find what will be the output of this OR gate. This OR gate is connected to these AND gates, and then in turn they are connected to these inputs. Now let us see what will happen here. Now this A is connected to this AND gate. Say AND gate number I am writing down. This is first AND gate and this is second AND gate. So this A is connected to the input of A first AND gate through NOT gate. So therefore the output of NOT gate will be obviously complement of input, right? But this A will directly going as a second input to this second AND gate. So this second AND gate is going to receive signal A again. Sorry, not A complement, simply A, right? Let me get the eraser, erase this. Okay, so simply what you are going to get is the A as a simple output, right? Now B. Let us take a look at B. B is now given as an input to second AND gate through NOT gate. So therefore, NOT gate will complement this signal as B complement. But this signal will be purely connected to AND gate. So therefore, this first AND gate will receive signal first as B. Wherever there is a dot, then that means that is connected line. That particular wire is connected at this position. Here there is, although there is a cross section, so therefore this is not connected. This dot, big circle, represents as connection. So therefore these are the inputs to the AND gate. So first AND gate receives inputs B and A complement. So therefore output of this AND gate will be B dot A complement. And for this second AND gate, it receives inputs B complement and A. So therefore output will be, right, B complement dot A. Right? Now these two are now entered as an input to this OR gate, right? This is an OR gate. So OR gate terminology is that place include plus sign between the two inputs. The two inputs are like this. So therefore, what I am going to do is I am going to write final Y expression is equal to B dot A complement. This is your first input plus B complement of B dot A, right? So this is your final output, right? Let us take a look at this equation. Now there are four inputs passing through some AND gates, OR gates, and NOR gates, and final output is Q output. And here it's a bubble. That means this is NAND gates. This is also NAND gate. Sorry, this is NOR gate. So A and B are inputs of NOR gate. Then output of NOR gate is equal to, it's a NOT OR, right? So first of all, I am writing down what will be the output of OR gate if inputs are A and B. So A and B are inputs. The output of OR gate, right? OR gate will be A plus B. But since it is not simply OR gate, it's a bubbled, right? Bubbled present at the output. That means it's a not OR. Not OR, that means it's a complement, right? So complement of A plus B will be now acting as an input to this one. Now this C and D, these two C and D are inputs of simply AND gate, right? So AND gate's output will be simple one, C dot D. Remember? So therefore these two now will act as an input to which gate? This is NAND gate, right? Right guys? This is NAND gate. But this NAND gate is nothing but equal to not AND, right? NAND gate means not AND. So what I will do is first I will write the output of AND gate and I will complement it as I have done here in this case also. So therefore Q output, or we used to write down Y, is equal to, let me write first of all AND gates output. So AND gate receives these two inputs. So first input is A plus B complement of this. And since it's a input to NAND AND gate, so therefore I am writing down the two brackets. Then dot, why? Because AND gates terminology, and dot. In the second bracket, I'm going to write C dot D. Okay. Now, this is written down for AND gate, but we want to find it for NAND, that is not AND. So therefore, placing this complement sign on these two inputs, right? So therefore, this is what you get as a output for this particular equation, in which there are NOR gates and NAND gates are involved. So whenever such type of situation has happened, first of all, try to imagine try to remove the NOT gate or bubble, and then write down the output for this specific gate, and then apply the bubble, that is apply complement sign above that. You can obviously derive this for next couple of steps. That is because in the previous video we have seen how you can use De Morgan's laws to reduce this particular equation also. But you can keep the answer as it is. There is no problem. So this is your answer of the question. Now let us see this one. Here there are three inputs, A, B, and C. Not AND gates, right? NAND gate is present, here NOT gate present, and here it is a AND gate present. We want to find what will be the Y, right? So first of all, let us see, A is given as a simple input to this NAND gate, and B is also given input to this NAND gate, and B is shared with the output is shared with final AND gate also. So therefore, first of all, let us focus, these two are the inputs to this NAND gate, which will be A and B respectively. These two, since are given to NAND gate, so NAND gate's output is not AND, right? This is a NAND gate which is equivalent to not AND, right? So AND gate's output would have been A dot B and uska not, so therefore it will be the output of this will be A dot B and the complement of this. So this will be complement of A dot B, which will be acting as one of the inputs for this AND gate, right? This is AND gate. Then this is one input. Then another input to this AND gate will be B, right? This B signal is shared between this NAND gate and this. And then C is coming towards this AND gate through this NOT gate. So therefore C will be complemented at the input side of AND gate. So now the AND gate, which is having three inputs, is going to receive three inputs like this: first one, second one, and third one. So Y will be equal to, you can write down Y is equal to first input as it is, so A dot B and the complement of A dot B dot B dot C complement of C. So this will be the Boolean expression for representing this equation, right? For this representing this circuit diagram. So let us see next circuit. Again, little complicated one, but we'll try to go through the all steps and it will be very easy for you then. This is OR gate and this is single one, so single output. So we want to find the output of this OR gate, that is Y. So inputs are this. This is a AND gate, OR gate, AND gate, AND gate. Now this first AND gate receives signal A as it is, and it receives second signal B as it is. Although there are two dots, that means another wire is connected which is given the signal B as it is to this AND gate. So therefore this AND gate, that is AND gate number say 1, is receiving signal as it is. So B will be received at the input terminal. So A and B are the inputs of AND gate. So the output of AND gate will be obviously A dot B. So here the input of this OR gate is A dot B, first input. Now let us see second. For this OR gate, B is acting as an input. So therefore input of this OR gate is B, right? Then another input C is acting as an input, so which is straightway coming to this. So therefore it's a C should be present. Since it is a OR gate, so output of OR gate will be B plus C, which is acting as an input for this AND gate. Now AND gate number 2. For AND gate number 2, the first input is C and second input is now you can see it's coming from B. This indicates there is no connection, it's a jump. So therefore wire is going above this wire, there is no connection, intersection nahi hai, it's not connected, right? So B. So AND gate number 2 receives signals as C and B. So therefore the output of this will be, right, C dot B. Now this is given as an input to AND gate number 3. So the output of AND gate number 3 will be B plus C dot C dot B, and inside the bracket. So now these A dot B and this are now acting as two inputs for OR gate, right? This is final OR gate present. So output of OR gate is place plus sign between the two inputs. So the two inputs are this. So Y output will be A dot B as a first input plus the second inputs are this entire. That means B plus C dot C dot B. Right, so this is the Boolean expression representing this circuit. Now let us see next one. Here 4 inputs are there, A, B, C, D, one output, this we want to find, but it is not directly coming, it is passing through NOR gate, NOT gate, and there is a OR gate, and then finally all the outputs are collected at AND gate. So let us see first. A and B connected to which gate? This is not any ordinary gate, it's a NOR gate, right? And NOR gate means not OR, right? Not OR gate. So what I will do? First of all, I will find the OR gate's output because it will be bubbled. So therefore output of OR gate will be A plus B and it's complemented, right? So this will be A plus B and complement of A plus B input to the AND gate. Then C is complemented and given to the AND gate. So therefore the AND gate, which is having 3 inputs, one input is this, second input is coming through NOT gate, so therefore it will be C complement, and final one D. D will be given as a input to this OR gate, and this OR gate receives another signal as C also, so therefore the output of this OR gate will be equal to C plus D, right? Now this AND gate receives 3 signals, 1, 2 and 3, and there will be dot between the between these 3 signals. So therefore the output of this AND gate, that is final output, which is representing Boolean expressions, will be like this: A plus B complement of A plus B, right, inside of one bracket, because this is the first input, dot second input is C complement, dot third input will be C plus D. So this is how you can write down Boolean expression for this circuit diagram. And now final one. The final one, we want to find X, the output of AND gate, which is receiving signals like this via so many diagrams. So this is A and B are inputs to this AND gate. So the output of AND gate, which is input to final AND gate, is equal to A dot B, right? Output of AND gate. Now this B will be given as input to this OR gate, but first it need to pass through this NOT gate. So therefore input of OR gate will be B complement. Then this OR gate receives signal C as an input. So therefore C is the input of OR gate. So output of OR gate will be B complement plus C. Now these two are inputs to AND gate. Therefore AND gate's output will be Y is equal to, the first input is 1 A dot B dot, second input is B complement plus C. So this is how you can find Boolean expression for this circuit diagram. So this is a very simple topic in which we have understood how to derive a Boolean expression with the help of given circuit diagram. The circuit diagram will be given to you, which involves different basic basic logic gates like AND, OR, then there will be NOR, there will be NOT, there will be NAND, like that. You are supposed to find the exact Boolean expression from using your concepts of respective gates. Okay, so this is very easy topic. You can easily find, if different diagrams are given, you can easily find Boolean expression for those respective circuit diagrams.